Alright, welcome back to my series on similar figures. This is the last video of the series where we're going to look at two figures that are defined as similar, and we're going to try to find some unknown values. In this example, we are looking at triangle UVW. The symbol is specifying that it's a triangle, is similar to triangle STR. Okay, that information is given to us in this problem. We are asked to find the measure of angle U. Okay, notice here, we are not told what U is. There's no value here. And we can't use the angle sum theorem because we don't know two of these values. So I can't start with 180 and subtract V and W to get back to U. That's not going to work here. So we have to come up with another strategy. All right, but if you go back to the first video in the series, I did define one of the conditions on figures being similar is that all of the angles have a corresponding angle in the other figure that's identical or congruent. Okay, and the way that we can figure out which angle it is in the shape is through the similarity statement. There's a lot of power in being able to write a similarity statement correctly. Okay, so unpacking this statement, I'm looking at this and I can tell right away that angle U is going to be congruent to angle S because they are the first letters that are written. And angle V is going to be congruent to angle T. And angle W is going to be congruent to angle R. Okay? V and T are given to us in this problem. We're given that V is 63 degrees and T is 63 degrees. That right there justifies this statement that V and T are congruent. We're showing that by showing that both of the angles are 63 degrees. Okay, we are only asked to find the measure of angle U. We're not asked to find the measure of angle R or angle W. We have R, but we're also missing W. But the question is asking us, what is the measure of angle U? And through writing our similarity statements, we've shown that U and S are going to be the same. And we don't know what U is, but we do know what S is. And if you recall from that first video, congruency means that they are identical. So the answer to this question, what is the measure of angle U? The measure of angle U is simply 40 degrees because it is the same as the measure of angle S. The measure of angle S is equal to 40 degrees, so therefore the measure of angle U is also 40 degrees. Okay? Our next example, we're going to look at trying to figure out a side length. Side lengths are a little bit more of a complicated question than the angle question, but that's just because we're dealing with some more numbers. Okay, so just like with the previous example where I was able to look at the statement and say, okay, well, I know that angle U and angle S are identical because they're both the first letters, I can also unpack what side lengths match up with which side lengths in the other figure. Okay, I'm dealing with three-dimensional figures, so I know that I'm going to have three fractions. Okay, I know that from my similarity statement, G and H are the first two letters, and W and X are the first two letters in the other statement. Then we have H and I, X and Y, and then the last one is G and I, and then W and Y. All of these fractions are equal to each other because it's given that these two figures are similar. I don't have to show it, I just need to accept it now because I've been given that information. Okay, our question is asking us to find the value of HI. Okay, let me use a different color for that. I'm looking for the value of hi. Now what I want to do is I want to start replacing some of these side length notations with numbers that I'm given in the problem. Okay, so I know that GH is 4. WX, I'm not given that information, so I'm going to leave it as WX. HI is something that we're looking for, so we don't have it. HI is going to connect to XY, which is 3. And then the last one, GI, is going to be 6. And WY is going to be 3. Okay, now I don't know what the scale factor is. I don't know how these sides are connected. But what I do know is that I have equal fractions. So one of the things we can do is HI is the value that we're looking for. HI is the value we're looking for. So I want to set up a proportion with 2 of these fractions. I want to have one of my fractions have the HI on it that I need, and the other fraction to be any of the other fractions that I have both values for. The first fraction, I have 4 over WX. I don't have both values, so for the sake of this proportion, I don't want to use it. Instead, I'm going to use 6 over 3. And I'm going to say that whatever the value of HI is, it's going to be equal to these 2 fractions being the same. Okay? And when we are dealing with proportions like this, and we're setting 2 fractions equal to each other, the way that we can work this problem out is through cross multiplication. Okay, cross multiply. Okay, and I think for the sake of this problem, I'm going to go ahead and define HI as the letter X. Okay, so when I set up my proportion, I'm going to change HI to the value of X. Okay, so I'm changing that so that it is a little bit easier to work with. Okay, now we're going to cross multiply. Okay, so we're going to go in diagonals. Okay, so one diagonal we're going to get 3 times x, which is just going to be 3x. And then on the other side we get 3 times 6. 3 times 6 is going to be 18. So by cross multiplying, what we've done is we've changed our equal statement with fractions into something that doesn't have fractions. Now we're dealing with an equation where we can solve for x. So this is a one-step equation. I need to get rid of this 3 by dividing it. So x is going to be equal to 18 divided by 3, which is 6. Okay, so the question is to find hi. The solution to this question is that the length of hi is equal to 6. Okay, the length of hi is equal to 6. Okay, that's 2 examples of how to find an unknown angle measure or find a missing side if you're given that the 2 shapes are similar. Thank you for watching my series. Good luck!